Welcome back, our viewers. We are actually at our sampling station B51, where we normally do profiling. We actually pick samples from 0.5 meters depth, 10.0 meter depth, at 20 meters, at 30 is 50 meters. So at the moment, the depth at this point is about 71.6 meters or so. So for the purpose of our demonstration, we are not going to do all the points. We are just going to do sampling at 50 meters. There it is. This is our sample from 50 meters depth. Multi-parameter, we are ready to read the results of the sample that we just collected. I'm sure you are following. So the temperature at depth 50 meters was 24.7. Then the electrical conductivity was 0.097 millisiemens per centimeter. Then the total dissolved solids was 63.16 milligram per liter. Then the turbidity at that depth was 0.84 NTU. Then the PC was 0.86 milligram per liter. Then chlorophyll A was 0.67 milligram per liter. FDOM was 6.49 milligram per liter. The dissolved oxygen was 2.17. The pH was 7.21. So the physical parameters such as temperature, pH, all those are done on spot, like I mentioned earlier, because we have to actually assess the quality of the water at that particular time, not when we carry it to the lab, because there will be so many physical parameters that can change the quality of water. Hello, our viewers, welcome back again. We actually sampled at 50 meters, and this is our sampling point called B51. We want to actually sample at 0.5 meter depth. So you will see and the differences of the parameters that we mentioned earlier, and these are pH, dissolved oxygen, as well as temperature. wait just a few minutes for our instruments to stabilize. For the mount parameters, it's already stable. So you heard earlier, the temperature that we measured was about 24.8 or 24.9. This time the temperature that is at 0.5, meaning near surface, is about 28.5. And the dissolved oxygen at this level, we wait a bit for this to stabilize. Then the pH, our pH is 8.43. Then our dissolved oxygen is about 7.43, which is way above what we had registered at depth 50 meters, which was 2.17. I'm sure you understand what I said, that the more we go down deeper at the bottom of the lake becomes anoxic, meaning there is little oxygen to support life. Only the anaerobic organisms will survive there. The aerobic ones will be actually occupying the surface part of the lake. So I'm sure we've demonstrated about what really goes on in terms of water quality in these deep lakes. Thank you so much for being with us.
We are just coming from D51 where we are doing our water quality sampling. We passed through Machinchi Bay Station. We sampled there just a spot sample from 0.5 meters. Now from B51 we did profiling from 0.5 meters and also 50 meters, and we compared the water quality parameter readings for temperature and dissolved oxygen, and you could see that the deeper you go, the lower the readings in terms of DO. As you come to the surface, the dissolved oxygen content improved from 2 to about 7 milligrams per liter. Yeah, just to summarize our mission, we conduct water quality monitoring on Lake KARIBA monthly from the eastern basin, and we also go to Vic Falls, other rivers like Sikalamba, Kanzinze. We also go to some rivers on the Zim side, Zimbabwean side, for Deka, Gwai. We do this monthly. Vic Falls, we also measure slightly upstream of the Vic Falls. We do that monthly. In terms of water quality monitoring, I've mentioned the weekly, the monthly on the Eastern Basin or Basin 5. Then we also do quarterly, where we go to the upper catchment, measuring from the tributaries on the Zambian side and also on the Zimbabwean side. Then biannually, we monitor around the lake. So we call that lake wide. So we go around the lake, we sample mainstream Zambezi and do profiling from Basin 1, the beginning of the lake, up to Basin 5. And then we also measure around the tributaries that flow into the lake. So you have the lake divided into 5 basins, Basin 1, 2, 3, 4, and 5. In terms of the water quality monitoring program, we do the physical chemical parameters, you heard Madame mentioned. We do bacteriological monitoring, that's the fecal coliforms. We also monitor the other parts when now you come to the chemical component. We also monitor the water hyacinth and other weeds using geographic information system and remote sensing. In terms of the water quality parameters, we also do spatial spread mapping around the lake. Otherwise, that's all for now.
Zambezi River Authority. Water today, tomorrow.